So hey guys, welcome back to my YouTube channel. So today's video will be on the topic that is topological sort. So we are going to see the topological sort by the both the traversal algorithm, that is DSF and VSF. So first of all, I am doing the topological sort with the help of the DFS algorithm. So topological sort means, first of all, we have to understand the term that is topological sort. What is topological sort? So topological sort is a we can say is defined as if I have a node U and V, and there is a directed edge between U and V. So according to topological sort, the this in topological, that is, it is a traversal. So it is a traversal. So according to topological sort, so u will be appear first. This u node should be appear first before appearing this v node. So so it is we can say this topological sort will be applicable only to DAG, that is directed acyclic graph only. And we have to because we need a directed edge between the two nodes, so it is applicable to the directed acyclic graph. So so topological sort means if I have an edge between u and v, so u node will be appear should be appear first. So let's say let me explain with the help of the example. Let's say this is my example. This is node 3, and this is directed to, sorry, this is node 5, and this is directed to node 2. So I'm taking the example of one graph. So this is directed to node 0. Okay, node 4 is here, and node 4 is directed to 0. So node 3, 2 is directed to node 3, and this is 1. 4 is directed to 1, and 1 is directed to 3 is directed to node 1. So the topological sort for this graph will be, topological order for this graph will be, that is 4 that is, sorry, 5, 4 and 2, 3, 1, 0. So what we are doing here is this 5 will be appear before the 0 and 2. Okay, so 5 is in our topological order. So this is my topological order. In my topological order, I have you have noticed that this 5 will be appearing before 2 and 0, that is 2 is here and 0 is here, and this 0 and this 4 is appearing before 0. Okay, so this 4 is here, and this 2 is appearing before node 3. So this is 2 and 3 before one node. 3 will the 3 should appear, so 3 is appearing before 1. So this is my this we can say order, and there are many topological order we can say present in a single graph. So there are many possibilities, we can say, which is present in the topological sort. So topological sort basically means if I have an edge between u and v. So if I have an edge between u and v, so u node should be appear first before v. So this is the topological sort. So we are so first of all, we are doing this topological sort with the help of the DFS algorithm, that is depth first search. So in depth first search, what we will do, we will take the help of stack, and what we will do, we will take the help of stack and visited array. This is stack, and one visited array, which is which have a size equal to the number of nodes. So in this case we have that is number of nodes is 6. So I have to make 6 size visited array, that is 0 1 2 3 4 5 and 6. Okay, so this visited array will keep track of our unvisited nodes. So initially I will simply initialize this vector, that is initialize this visited array to to false. All the nodes are not reachable from each other, so I will mark all the nodes to false. So what I will do, simply I will make the DFS calls for a particular node, and uh, let me explain let me first maintain we can say uh, write the adjacency list of these nodes. So 0, from 0 where I can go, from 0 I can go nowhere, so this will be empty. From 1, from 1 also I can go nowhere, so from 1 there is no outgoing edge. So from 2 I can go to node 3, from 2 I can go to node 3, and from 3 to I can go to node 1. Okay, from 4 I can go to nodes 0 and 1, and from node 5 I can go to node 0 and node 2. So first of all we will mark all the nodes unvisited. So I will mark all the nodes unvisited. Okay, now what I will do, I will make the DFS calls from this, let's say from 0, and what I will do, first of all I will mark visit. So this will be marked as visited, and what I will do, so I will push this 1 into my stack. Okay, and now I will explore the neighbors of 0. As we are seeing that there is no neighbor of 0, so we will iterate over next, that is next node, that is 1. So we will mark the 1 as visited in my visited array and insert this 1 to my stack. Okay, now my stack become, that is first will be 0, and now that is 1. Okay, now 1 will be inserted. Okay, after that let me zoom out this. mm, okay, so next I will see the neighbors of 1. So there is no neighbor of 1 is present, so I will move to the next node, that is 2. So I will mark first the 2 will be visited, 2 will be marked visited, and I will see the neighbors of 2. So from 2 I can go to node 3. So I will mark the node 3 as visited, and what I will do, I will push the neighbors of 2 before 2. Neighbors of 2 will be 3, 3 will be pushed inside the inside my stack before that is 2. So that is 3, and 2 will be at top. Okay, and now what I will do, I will move to the next, that is 3 will be already visited, so no DFS call will be done for 3 node 3, and I will visit node 4 and node 4. So I will mark node 4 as visited, and I will explore the neighbors of that 4. I will explore the neighbors of 4. So neighbors of 4 are already visited, as we have seen, we have marked true in the, we can say, visited array at index 0 and 1. The node 0 and 1, these are visited already, so we will not call the DFS for node 4, neighbors of node 4s. Then we will move to the next, that is node 5. Then neighbors of node 5 are 0 and 2. So first of all we will mark the node 5, that is true, and we will see explore we will explore the neighbors of 5, that is 0 and 2. As we seen that 0 and 2 are already visited, so we will not make any DFS calls for the neighbors of this 4. So we will simply insert my this 4 into my stack. So now what I will do, I will call the DFS for the next node, that is 5. So 5 will be marked as visited, that is true. Okay, that is marked visited true. So 5 will be inserted inside my stack. So my stack will be containing the topological order, that is 5 4 5 4 2 3 1 0. So this is my, we can say, topological order of this given graph. So this is my topological order. So simple funda is for this topological sort is in 3, we can do in 3 steps. So simple, we can say, in lame terms, we can say what we are doing here is we are simply, when we are doing the DFS call for the particular node, let's say X node. So what we are doing here is we are inserting the neighbors of X before the inserting the this parent node. So we are including the we are inserting the nodes of this parent, we can say children of this node before the parent nodes. For example, let's say this neighbors of this X is Y and Z. So we are inserting the Y and Z into stack before the X, that is parent, before the parent. So first we are inserting the childrens of the that node, and then then we are inserting itself. Okay, then we are we can say inserting the parent before after the, when we are inserted the childrens. So this is the simple we can say simple concept behind this, as we are doing simply inserting the childrens of the nodes before inserting it. So this is for it for this DFS, we can say topological DFS traversal. So let me once explain with the help of the code also, so you can easily get the idea how the things can be done easily. So let me explain with the help of the code also. So simply what we are doing here is we are maintaining a visited array. That size of that visited array is equal to our number of nodes. Okay, initially we are we are storing, that is mark unvisited to all the nodes, and we are taking the stacks, and we are we are visiting to making the calls in making DFS calls in every node, and we are exploring the neighbors of that particular node, and if the neighbors are present, we are inserting the neighbors into the stack before the parent node. So once the we have all inserted all the neighbors of that particular node, at the end we are inserting that parent node, and at the end we are simply the stack will contain our, that is topological order, and we are simply storing that stacks element into my answer vector and finally returning it. So this is the topological sort with the help of DFS algorithm. So now we are implementing this topological sort, that is topo sort. In short form, we tell that is topo sort. So with the help of we have done with the help of DFS. Now we are doing with the help of VSF. So VSF means that is breadth first search, and in this breadth first search we are traversing the nodes in level wise. Okay, level wise. So in VSF, so in this with the help of VSF, how can we can done with the help of VSF is we are in VSF algorithm we take the help of Q data structure, that has principle, that is first in first out concept, based on the first in first out concept. So what we will do, we will what we will do, we are counting the in degree order concept. So we will count the in degree of each node, and if the in degree of particular node is 0, we will push that element first into my queue, and we will push that node into my queue, and after that, so this is the, we can say also, this is also called the Khan's algorithm. And in topological sort, node u will be always before appear node v if a directed edge between node u and v towards v. Okay. mm, so in VSF, so this is called the Khan's algorithm. I have already tell that. So here we are using the VSF algorithm. So approach will be simply, what we will do, but rest first search will be based on the, we are traversing the nodes in level wise order, and if we will visit the nodes in the same level simultaneously, and then we will move to the next level. Initially we will take the in degree order array and queue that will required for the BSF algorithm. So the node with in degree 0 will be pushed into the queue first, and the answer array that will be contain our linear order. So first of all we will calculate the in degree of each node and storing it into the in degree array. Okay, then we will iterate over our adjacency list, and simply for every node from u to v we will increase the in degree order by 1. Okay, so I will simply here I will explain with the help of this code what we are basically doing here is simply, so first of all what we are doing here is we are taking an in degree, that is in degree array that is size equal to our nodes. So let me explain with the help of taking one example, that is so let's take this easy example, that is 0, this is 1, this is node 1, this is node 2, and this is node 3. This is node 0. So let write the adjacency list of, that is 0 is, that is no one So from 0 we can't go anywhere, so there is null. And from 1 we can go to 0, 2 also we can go 0, and 3 also we can go 0. From 3 also we can go to node 0. So what is the order of the topological sort will be? The 0 will be appear, we can say 0 should be appear first. So okay, 0 should be appear before all the nodes. So this will be 0, 1, 2, 3 will be the correct order of, or we can say there are many possible topological orders. So this is one of them. So first of all we are doing, maintaining this in order, that is in order array, that is in order vector, or we can say array. So this will be what it will contain the in degree of the each node. So size of the node in degree will be that is equal to our given graph, that is given node, that is 4 equal to 4. So that is 0, 1, 2 and 3, and initially in degree of all the nodes is 0. Okay, after that what I will do, simply iterate over the adjacency list and simply calculate the in degree for each node. So in degree of 0 will be, that is 3, and in degree of 1 will be 0, 2 will be 0, because no edge is coming into the that is node 1, and node 2 also, and node 3 also. Now I have maintaining the Q data structure. So Q data structure is also, let's say this is Q data structure. So let's say this is my Q data structure. Let's say it is denoted by Q, and what I will do, I will put all the nodes that has degree 0 into my this Q, that is node 1, node 2 and node 3. Okay, after that this topological another vector, that is topo, that will store our answer. What we will do, I will first in this Q data structure is based on the first in first that is first in first out principle. So the node that is Q dot front will containing the node 1. Okay, Q dot front will be containing the node 1. Q dot front will be containing the node 1. So here Q dot front will be this 1, and this will be inserted into my vector, that is 1, and after that it will be popped out of my this answer vector. Okay, after that I will see the neighbors of this one, that is 0, and in degree of 0 will be 3 reduced to, that is 2, and in the next, that is this 2 dot front will be come, and this is 2, and the in degree will be reduced to 1, and 3 will become, so in degree will be, that is 0. So this is the topological order, we can say.